Hello everyone, welcome. Today we will discuss about electromagnetic induction. In this video, I will tell you about every concept related to electromagnetic induction. After watching this video, you will not have any doubt in your mind. Let's begin. See, what is electromagnetic induction? See, if I say I have three things. What are these? Force, magnetic field and current. From these three things, I will tell you the whole concept of electromagnetic induction. Just focus. See, we all know about force, we all know about electromagnetic, we all know about magnetic field, and we all know about current. See, what happens here? If we provide any two of the things, we will get the third thing from the above three. See, what happens here? If we provide force, if we provide magnetic field, we will get current. Okay, you got that point or not? See, here I will show you how it works. See, if there is a bar magnet, see how it works. In this diagram, we are seeing that ammeter is showing a zero reading on its needle. That means current is not flowing in the circuit. The circuit is closed. You can see the circuit is closed. The coil is wounded around the soft iron, and here is an ammeter is connected, and the circuit is closed. The ammeter needle is pointing upwards. That is, it is pointing towards zero current. The circuit is closed and there is no current is flowing in this circuit. In all three circuits, we can see the same thing. Now, how it works? Here it is a bar magnet. Okay, here it is a bar magnet. See, this is how the magnetic field works from now north pole to south pole. So this magnetic field will flow from this and will again enter the south pole. This is how it works. But here I am providing only magnetic field. What about the force? How and from where will this force comes, and how it will induce the current in the circuit? See what happens here. When I will move this bar magnet towards the coil, what happens? What happens? It will change the flux. See, this is what flux is. This magnetic field lines flowing from north to south, this is the flux. This magnetic field lines, when it will change in the coil, when it will change or cut this flux, when it will change in the coil, how it is changing? When we are moving the bar magnet towards the coil, the magnetic flux is changing, or the magnetic flux linked with this coil. The magnetic flux, this is the magnetic flux which is linked with the coil. This will change. When this is changing, so we are getting force. Okay, by our force, this magnetic flux is changing. Magnetic field is also already there. When it is moving towards the coil, the ammeter will show. The ammeter will show you the reading. See, when ammeter is showing you the reading, that is the current has started flowing. The current has started flowing. How it is flowing? We have provided force in the form of magnetic field. Change in magnetic field. Magnetic field is provided by the bar magnet, and the change is provided by us by moving the magnet. So we will get the current. Okay. Here how it is working? We are providing force in the form of change in magnetic field. Okay. We are providing magnetic field with the bar magnet. Now see, when the bar magnet reaches here and the movement ceases, what happens? Bar magnet has reached here. Okay. This is the flux, and the bar magnet, the movement of the bar magnet is stopped. I have stopped the movement of the bar magnet. Now what is happening? Magnetic field is there. Movement has stopped. So what will happen? There will not be any change in magnetic flux. That is, we are not providing force. So the ammeter will again show you. Zero reading. Okay. So here we can observe that the change in magnetic field is necessary. Only magnetic field is not necessary. The change in magnetic field is also necessary for the current. Okay. So it depends on three factors. Now you have understood what is current. It is the induced current which is coming in the circuit. Now let me tell you what happens here. If we increase the strength of the magnet, the magnitude of induced current will increase. If we increase the surface area, when we will increase the surface area, the area which will be cutting the magnetic flux will be increased, and when the area will be increased, the current will also increase. Okay. And what I have told you, the strength of the magnetic field, the surface area. What can be the third thing? The rapid motion. ठीक है? What happens here? When we will increase the pace of the motion, that is how fast the bar magnet is moving and how fast the magnetic field is linked, the magnetic flux linked with the coil is cutting it, how far it is getting crossed. Okay. Speed of the movement. On these three things, the induced EMF will depend. So let me tell you how it works. Let me tell you the definition. See. So what happens in the definition? Whenever there is a change in magnetic flux, an EMF is induced in the circuit. This EMF, see, whenever there is a change in magnetic field, magnetic flux, an EMF is induced in the circuit. Okay? An EMF is induced. What this EMF is called? This is called induced EMF. What it is called? Induced EMF. This is called electromagnetic induction. The whole process is called electromagnetic induction. Okay? Thank you.